Okay. Hello, everyone. Today is, I need to check the date. Today is 7th February, and we are here for Topology Where Scheduling Sync. We have a few items on the agenda, so let's go through them. The first item that I put in there was internally we were having conversations around, what the upstream backlog looks like for Topology Where Scheduling. So I just threw in a few kind of lines that at least in my head represents the upstream backlog. So I wanted to get some feedback on what you guys think, if you think this is a reasonable representation, if I'm missing anything. And there were a few items I think I wanted to even get feedback on if it makes sense to do. So kind of it's an open kind of forum for people to kind of comment on this item. I think I kind of tried to organize them based on the way I saw them at least being implemented or in terms of priority, but yeah, kind of open to input.
I think item D and E, the last two, they tie nicely with the dynamic resource allocation cap, which is the next item, because both of them, they could be, well, one way to implement them, to address them, could be at least partially using the dynamic resource allocation cap or extension of it.
Okay, yeah. And then like in terms of, I think, watch support, so that's something that we're targeting for 125. I think we kind of need to push a bit on that. Like I remember Francesco mentioned to me that we should maybe have like a pulse check, maybe every meeting to see if you're making progress and at least finalize or have conversations around the design. So I think we'll start working in that direction from the following meeting. Like I'll just put in a column for us to kind of keep a check on how you're progressing with the watch support and pod resource API. The other one that I was kind of thinking about was resource topology exporter and NFD topology updater. I think you have a few items here, but like what I was thinking was that resource topology exporter has a few capabilities, like for example, the smart polling. But given that we are planning to work in to enable like the watch support and pod resource API, does it make sense that we maybe enable just the watch support in NFD and skip the smart polling capability? Another way of asking this question would be, once the watch support is enabled in pod resource API, would we keep the smart polling capability in RT in addition to watch, or would we be removing that?
From my perspective, watch implementation is the preferred way to go for NFD. Actually, if I'm not mistaken, the maintainers actually explicitly said so. So in my opinion, NFD should just consume the watch API, probably be the first consumer. I mean, nothing wrong to use RT as a test bed, like test bed for the watch, but the very first, let's say, official consumer should be, in my opinion, NFD. Regarding RT, I was doing some work on it lately. Red Dot did quite some work on it lately, but from us, nothing changes, meaning NFD is still the preferred way to go. And the thing we envision the user space to, not the user space, the updater to consume the pod resource API, the official way, let's say the recommended way. Meaning that RT, for my perspective, is quote unquote done. Meaning, okay, it serves these purposes, it is a useful demonstrator, but from now on, once we want things to be like as designed, NFD is the way to go. On the other end, there could be circumstances in which we still want to prototype things, but in a very, very, very defined and limited way, meaning, okay, we are not sure how the final API looks like, so okay, let's try out a trivial, test program But besides, I mean, I don't even see as PR getting merged in RT, maybe posted to try things out, but not even merged. Okay, this is, however, my take. So I will be happy to discuss if everyone has a different perspective.
I think I kind of echo that sentiment as well. Like that's how I see RT as well. Like for us, given that there are certain capabilities that we might want to implement and have the independence to implement and play around with it and learn from it. RT is like a great kind of repo for us to do that, and then we can try to bring try to make sure that RT and NFD are both at the same level, and then eventually at one stage we wouldn't need RT at all. Again, I don't know. It might be that we still need it for I don't know, future things that we need to do. But I think I agree with that. So like the way, for example, the smart polling or some of the capabilities that are currently implemented in RT, you're saying that we would it would be superseded by, say, the watch mechanism in Power Resource API. And so, like, I think that makes me feel that maybe then it's better for us to invest our time in enabling, say, the watch capability and kind of put more effort into that than trying to make RT and NFD be at the same level in terms of their features.
I think that, okay, in terms of actual implementation, how do you consume the API, how the code will look like, RT, because it happened to be our test bed, it has some features, the code is a bit better implementation-wise than the code that find its way on NFD.
Yeah.
On the other hand, since we will need to do quite some larger refactorings on NFD when time comes to consume the watch API, maybe we should just retarget a bit our goals and like, okay, things like the end-to-end test suite, they're easy to consume because they consider the implementation as a black box. So, okay, they're totally worth pursuing. But further refinements, they think they can be postponed and invest our time in the watch design.
Yeah,
And
I think.
Sorry, go on.
Yeah, that's what I think as well. So yeah, that's what. Feel free to continue. Sorry, Francesco.
Yeah, using Watch API will require appropriate Kubernetes version. So as a fallback, you can keep a previous approach also.
Exactly. This is exactly where I wanted to go, meaning that what we call smart polling, which is a kind of assisted notification. For example, the last iteration we had for smart polling was inject cry hooks to wake up the RT and say, okay, now I know I need to update. So this is why the poller is smart. This is of course is worse than watch, because watch is telling you, hey, I have fresh data and here is the fresher data. Now you can, okay, something changed, go and fetch it. So of course it's worse, but on the other end, it works less than ideal, but it works now better than pure polling and without changes. So in that sense, is something we can evaluate proposing, but unfortunately our time is limited. So proposing when watch is in good shape as okay, you want to support, say, Kubernetes 2123 or 124 or 125 up until the watch goes beta, say, then okay, maybe later we can propose that to NFD folks. But again, on one end, I wanted to highlight this capability, which is important to mention, I believe. But on the other end, I still believe the priority should be towards the watch side, which will be interesting. And now I'm done.
Yeah, I think we are pretty much all aligned, I feel, in terms of that. Any questions on that before like I jump on to like say other items? Okay. Okay, so I move on to the next one. I think then this one was kind of a generic one that I put in there, like optimization, the scheduler plugin, reserve plugin, which I think Francesco has a PR on that open, and we're going to kind of resume looking into that. But then the other thing that came to my mind was, I remember I had submitted a PR in scheduler plugin repo where we were, I think, trying to evaluate in case we don't have an NRT object present for a particular node. In that case, I think we were just not considering that at all, that node at all. So I think we had discussion around like, even if the node does not have multi-NUMA hardware, and it has just a single NUMA or single socket system, in that case, do we still expose NRT like CR corresponding to that node? Like, is that something we should maybe invest some time? And I think it's not going to be a lot of effort, but some effort. But there would probably be some changes needed in the scheduler plugin side to address that. But overall, I think it'll be nice for us to have visibility into all the systems in the cluster that are present, as opposed to just multi-NUMA systems.
But we don't need to fix that in the scheduler plugin, do we? Because okay, you are inside the RT or NFD and say, hey, this system happens to have just one NRT, so I don't bother publishing it.
Yeah, so I think the way I saw it was that, given that, imagine there's a scenario that you have two nodes in the cluster. One is a multi-NUMA system and one is not. So in that case, the scheduler plugin would only consider the node that has multi-NUMA systems, and because we'd have the NRT CR object corresponding to just that, and we wouldn't be considering another node which might have enough resources and would be able to fit all the resources, say on single NUMA, but we won't consider that. The scheduler plugin would not consider that.
Okay. The first question I have is that I am not sure at all those kind of mixed environments are common.
Yeah.
So if it is important to address them, then I think we can evaluate. But the point I'm trying to say is that this optimization can be solved also in the updater side, not on the producer side, not necessarily on the consumer side.
Yeah, so I'm actually talking about the updater side itself.
Go on.
Yeah, so like I'm saying that in NFD, we expose NRT-CRs corresponding to the nodes that have a single NUMA. So this is actually, I should have mentioned that actually, exporter side update.
For example, we don't have a business case where we need to choose among just single NUMA node, worker node, or multi-NUMA node, worker node. But if this case will rise, it could be solved just by two scheduler: the general scheduler responsible for nodes without NUMA nodes, and custom scheduler with plugin with NUMA awareness plugin. So yeah, it's not a scheduler issue, I think. So in this architecture, if we have such a worker node, we just need to direct our port to appropriate a scheduler, which doesn't have a scheduler plugin for NUMA awareness.
Okay.
I agree with Alexei.
Okay. What to do appropriate schedule?
Maybe I'm missing something, but Swati, according to your example, it sounds like having this optimization will require additional work, but with the current implementation, the scheduler plugins has also an OT object which represent only single NUMA nodes.
We don't.
So
That's
what's the...
So it
Go ahead.
doesn't. Currently, it does not. If you have only a system which has only single NUMA node, you don't get the resource information populated. Only if there's multi-NUMA nodes in the system, that's only when we expose all the available resources and things like that. Again, I haven't tested it myself, but that's my understanding.
Just one comment. When you say you don't have, you mean NFD or RT?
Yes.
Can you elaborate on the question?
Because changes we made in RT
Yep.
make, well, RT at this point in time doesn't mind. I mean, okay, I'm running on a single NUMA.
Exactly.
Okay,
I don't mind.
okay.
You ask, you get it. NFD, I don't remember, so you could
Okay.
totally be.
Yeah.
And if you wonder, that was not deliberate. We didn't know about me and others which did the RT changes. We didn't know, okay, if you want to have mixed environment, if you, we just believe that resource pooling, how do you define the node pool, like Alexei mentioned, solved that transparently. So we didn't bother adding this check.
Okay. So like, is the statement correct that RT currently exposes hardware topology in case of single NUMA? Okay.
Yes.
Okay. So yeah, maybe it's just a matter of seeing if NFD does that as well. But like I hear you guys, like you're saying that it's probably not the most bang for buck in the sense in terms of our time. Like if the scheduler itself, like if in the pod itself we can decide the scheduler, it should solve the problem. But it would be kind of a nice experiment just to evaluate what is the state of NFD in case there is a single NUMA node system. So yeah, okay. So I think I'll move on to the next item, I guess. I think, yeah, these next two items, I think, Francesco, you said, but this one I think is about moving the API itself to Kubernetes org. So this is probably going to be less less invasive than this one, but probably going to involve less conversations, given that there's already a directory corresponding to this repo that exists. But I just wanted to capture it there. Okay, so I think we covered. So thanks, kind of, for answering some of my questions on this. I'm going to probably move to the next item. So this is a very interesting feature that has been proposed by Patrick Oley from Intel. He's been kind of working really hard to enable this capability, and it's an interesting one to read for those who haven't seen it. And it's very complicated as well. I think I've read it twice, but I still feel like I need to read it 2 more times to get my head around it. So we were asked, there was a question about NUMA and topology where scheduling overlap asked. I left a response there kind of in terms of what I see that we need for topology aware scheduling to continue working with that solution as well. But I think there are a few questions that need to be answered because it's not clear when exactly do you consider resource actually allocated to a particular pod, because some of them are ephemeral and all those things. Like it's very interesting, and it's not kind of challenges the way we see resource allocation, because like currently kubelet is responsible for resource allocation, but I think in the proposal that Patrick has, it happens at a lower layer. So it's going to be interesting, like when do we consider that resource to have been allocated, and then how does that get exposed outside Kubernetes, or at least kubelet, in the sense like the way we have pod resource API. So yeah, like again, Francesco, I think you were reviewing this one as well. Any thoughts, comments? Yeah.
Yes. Well, first of all, I totally agree with Swati. It's very interesting, but still need to review it to grasp all the details. So the points I would like to raise and to highlight to this forum is that, first of all, I do believe that possibly an extension of this framework, should it be accepted, could be a way to re-implement the current capability of the topology NUMA-aware scheduler, but that will be re-implementation, not like, hey, it used to be, say, node resource topology, now it is dynamic resource, whatever, everything gets unchanged. No, it will be, changes will be needed because the proposal changes the way the resources are allocated and accounted also significantly. For our goals, I see 3 gaps. I mean, in the current state, not the blockers, but there are 3 gaps we can maybe address. The first gap is, by design, this proposal addresses devices, which is great, but we also need to care about the CPU and memory, which could or could not be something they have in scope, they're already willing to support, so we will need to see. And we'll need to evaluate the overlap if we go this way with the CPU manager and the memory manager. The second thing is, I need to review, but I didn't say NUMA affinity and mention it anywhere. So you see, we are still somehow reviving the past on which we need to expose those things. And the third thing I want to, well, this could be relatively easy because could be yet another attribute, but still need to be taken into consideration. And if someone is wondering, hey, if they are not exposing NUMA affinity, how is this going to interact with the topology manager? Good question. I don't know. I need to review that as well. Yeah. Last point, and I'm done, is the problem in this case, well, it's not the problem. It's an interesting design decision. They want to decouple the resource advertisement with the resource tracking, status tracking, meaning to learn, as well, I may be wrong, I need to review, but the way they want to say is that you have this resource driver, which is exposing somehow to the cluster. Hey, on this node, I have this bunch of devices, and then to consume them, you send a resource claim, much like volume claim, and say, okay, I want 2 devices, and then the magic happens, and all the pieces together start talking and interacting, changing the resource claim status, which is great. But the part which I want to spend more time reviewing is that, okay, great, but how do you advertise your resources to the cluster? How do you know that device, wonderful device ABC exists even, so you can claim it? How do you know? And that part, if I remember correctly, should be exposed in a generic way using custom resources, which brings us a bit back to the square one, because custom resources, the scheduler plugin cannot consume custom resources, should not depend on custom resources. This was clearly stated by the scheduler people and also acknowledged in the CAP itself. So we'll need to see how they want to solve this problem they already have, and maybe we can build on top of that.
Yeah, I think you're right. My understanding is correct as well. Like when it comes to this, the plugin itself has to be responsible for managing its own advertisement of resources. And how it does it, it's kind of up to the plugin itself, and it's done by a custom resource. So yeah, that is an important point. And I think these 2 things, when I reviewed initially, I assumed that was a deliberate decision, because like the scope of the CAP itself is like massive, and like I assumed that they want to limit it in some shape or form. So they were like, okay, let's just tackle devices and then try to figure out CPU and memory and NUMA affinity and all those things later. But this might kind of bite us in the back, because if we kind of create an API just considering devices and not considering other resources, it could kind of backfire later. And like we could shape the API in a form that these other resources and NUMA affinity, for example, we cannot kind of come back and enable the capabilities that we need for these particular resources.
There are 2 two things I would like to add. The first thing is you are totally right that the cap is massive, so not mentioning CPU and memory absolutely makes sense by all means, but the lingering question is, okay, you folks, you do want to coexist with the device plugins, let's say old style device plugin, which is great, but how do you plan to interact with Topology Manager? Because if this dynamic resource allocation wants to interact, and I'm not sure they want, because really I need to read it again, then you will need to, well, send some topology int, and then you are back to expose NUMA affinities somehow. So that part ties again on, okay, how does this new feature interact with the existing framework, and where the line is drawn?
Yeah, I think Sasha from, I think he's working with Patrick, I believe. He commented on the CPU management doc that Marlo had shared that topology affinity and kind of alignment with topology manager is not out of scope, and that was a deliberate decision. So yeah, but let's see how that kind of gets tackled. But it's an interesting one. Like, I think all of us should at least take a look, just be aware of it, because it was being targeted for 124, but it got pushed given the massive scope. Like, they're making changes in the API, they're making changes in controller manager, scheduler, kubelet. So that's like, I would have been massively impressed with Patrick if he got it in 124. Like, I was almost anticipating that it'd get pushed, but he's doing a good job anyway, like pushing this and keeping everyone up to date. So yeah, that is it. I think we are bang on time. Any other opens before we wrap up? Okay, cool. Thank you, everyone. Thanks for your time. See you in next 2 weeks. Bye.
Thank you. Bye.
Right.